Hello math learners! How was the discussion about our two previous videos in terms of rational algebraic expressions? I hope you got it all covered because today we're going to have another discussion about another operation on rational algebraic expression, and that is addition. So, before anything else, hit the subscribe button and notification bell for you to be updated of these cool clear math videos just like this. How are you doing, math learners? This is your free access math teacher Ash, and welcome to another session here in ML with Sir Ash. For today's lesson, we're going to discuss the most essential learning competency-based lesson for Quarter 1, Week 4 of the Grade 8 Mathematics. And this is all about adding rational algebraic expression. So now, let's talk about the third operation, which is all about addition. Okay. So, in adding rational algebraic expression, there can be two scenarios. The first scenario is that you will have the same denominator, and the second scenario is that you will have different denominators. Now, let's talk first about the first scenario. When your fraction is added to another fraction, or when your rational algebraic expression is added by another rational algebraic expression, and they have a common denominator, then you can just copy the denominator and then add the numerators. Remember that when adding numerators, always combine like terms. Okay, next, what if we have a different scenario in which we have a different denominators? Now, if you have different denominators, let's say B and D, what you will do is you will get the LCD of those denominators such that you will obtain its LCD. So in this scenario, we have BD. But remember, our numerators will need to be multiplied by those LCDs because that will serve as a new equivalent fraction for that given fraction. But do not worry because we will consider actual examples for that matter. Okay, now let us start. How do we understand this addition of rational algebraic expression? Now, let us have first a quick review on how to add fractions. Let's say we have a given 1/2 plus 3/2. Okay. So, in this scenario, we have a common denominator. So, what you will do is you just copy the denominator and then directly add the numerator. So, that is 1 plus 3 and the answer is 4. Now, if the case will give you a scenario in which you can still simplify it, then you should get the simplification of it, whether it is lowest term or just a mere division. So, as you can see here, 4 can be divided by 2. So, 4 divided by 2, the answer is 2. So, this will be your final answer. Easy, right? Okay, now let us consider another set of problem. Okay, math learners, we are here in our second example, still on fractions. We have 1/2 plus 3/5. Now, this is what we call dissimilar fractions because they have different denominators. Now, the question is, how do we add fractions that have different denominators? So, technically, what you will do here is you will get the LCD or the least common denominator. So, you will make a long line. What is the number in which 2 and 5 are factors? So, basically, if you will count by 2 and by 5, the first number in which they will have the same multiples is 10. Okay. So, this 10 will first be divided by here in order for us to get the equivalent value. Okay, so this is how it goes. 10 divided by 2, that is 5. That 5 will be multiplied in the numerator. So, 5 times 1, that is 5. So, you just copy the plus, and you have now the equivalent of 1/2, that is 5 over 10. Get? Alright. Now, there is also another way of how to get the equivalent fraction. This is what I call the ask yourself. What happened to 5? Why it became 10? It was multiplied by 2, right? So, therefore, you also do the same process in your numerator. So, 3 multiplied by 2, the answer is 6. So, by simplifying this, we have 5 plus 6, that is 11 over 10. And since 11 over 10 is an improper fraction, you can still simplify this or get the other form of this one by considering the mixed number. Okay, and that is 1 and 1 over 10. Easy, right? So whether this is your answer or this is your answer, they are still the same. Now, let us consider some numbers and variables, which is actually the rational algebraic expression. Okay, math learners, we are here in our first actual example for rational algebraic expression. So we have x squared minus 2x minus 7 over x squared minus 9 plus 3x plus 1 over x squared minus 9. Now, first is you observe the given. Okay, our given fractions has the same denominator. If that's the case, then you can just make a long bar with the denominator that is the same. You just copy them as 1. Okay, so that is x squared minus 9. Then, after that, you will combine all your numerators. So we have x squared minus 2x minus 7 plus 3x plus 1. Now, the question is this the final answer? Not yet, because we will combine like terms in our numerator. So, what are the like terms here? We have x squared, which doesn't have any x squared on the remaining terms. We have 2x, and we also have 3x here. So, that is negative 2 plus 3. That will give us positive x, positive 1x. Okay? So, this is the like terms. Next, we have negative 7 and positive 1. Both are constant terms. So, negative 7 plus 1, that is negative 6 over x squared minus 9. Easy, right? Now, for other students, they will automatically consider this as their final answer. Remember this, my dear math learners. Let's go back to our ideas or what we have learned in multiplying rational algebraic expression. Remember that as long as you can simplify your final answer, in which you can break them down into factors and you can cancel identical binomials, then try to do so. Okay, remember that this is a trinomial and this is a difference of two squares. So therefore, somehow, we can say that there are factors for this one. Okay, so this will be factored out. So x squared minus 9, the factor of that is x plus 3 and x minus 3 and x plus 3. Then, for the x squared plus x minus 6, we can have two factors, okay? We factor the first term, that is x and x. And then we factor negative 6 such that when we add them, the answer is positive 1. So that is positive 3 and negative 2. Because positive 3 times negative 2 will give us negative 6. And positive 3 plus negative 2 will give us positive 1, which is our middle term. Okay, now we have the factors. The next thing we should do is we will check for identical factors in the numerator and in the denominator side. We have x plus 3 here. We also have x plus 3 there. So you can cancel them. Okay. X plus 2 here, x minus 3 here. So they cannot be cancelled. Therefore, we have our final answer as x minus 2 over x minus 3. And that will be your final answer. Is it right? Now, let us consider another example. Okay, math learners, we are here in our second example for rational algebraic expression. We have 5 over 18a to the 4b plus 2 over 27a cubed b squared c. Now, the first thing you should do is you check first the denominator. Now, what we have here is dissimilar fractions. They don't have the same denominator. So what we do is this one. This would be very challenging for you guys somehow because first is we will get the values or the correct multiples of these denominators. Okay, now, what is the technique here? The first thing you should do is you make a long line, okay, which is the bar or the over. Then you get the highest exponent of the variables. So the highest exponent of a here is a to the 4th, okay. For b, we have b squared, all right. And for c, this doesn't have any c, but we have a c here. So we'll copy the c because since that will serve as the highest exponent for that particular variable. Okay, now, Let's go to 18 and 27. Now, what is the number in which we find that 18 and 27 as factors? Okay, you can use the least common multiples. Now, remember, in the least common multiples, you can consider the prime factorization. The prime factors of this one is 2 and 9, right? However, 9 can still be factored out to 3 and 3, all right? While 27, we have 3, 3, and 3, because that is 9 times 3. All right. Now, what do we do here is we copy all the factors. Okay? Copy all the factors. So, that will serve as our LCD. So, what we will do here is we will multiply all the LCDs. We have 2 times 3, that is 6. 6 times 3, that is 18. 18 times 3, that is 54. Alright. So, our LCD is 54 a to the 4th b squared c. I hope you got that one. Remember, what I did in the variables is I copied the highest variable. This is only applicable for our monomials. Okay, now we have our LCD here. What we will do is we will divide this LCD to our previous denominators and the answer will be multiplied to the numerator. Okay, sounds easy, right? Now, let's do the process. 54 divided by 18. So, let's just write the 5 here so that you can follow me. Okay, 54 divided by 18, that is 3. Okay, A4 divided by A4, none. B squared divided by B, that is B. C divided by nothing, or C divided by 1, it's still C. Alright. We copy the plus. So, we are through with our first. And now, let us go to our second fraction. So, we copy 2 here, okay? And then, we divide this one to this one. So, 54 divided by 27, that is 2. A4 divided by A3, A cubed rather, that is A. B squared divided by B squared, 1. C divided by C, that is 1. So, therefore, we only have this answer. Now, you just simplify this one, and this is 5 times 3, that is 15BC. We have 2 times 2, that is 4A, with the A there, over 54, A to the 4th, B squared C. Now, we cannot add 54BC to our 4A because they have different terms. This has an A, while this one doesn't have an A, except they have a BC. Therefore, this will be our final answer. Sounds easy, right? Okay, now, let us consider some polynomials or some algebraic expression in which we have binomials or trinomials with different denominators. Okay, math learners, we are down to our final example, which is a fraction added by a fraction by which the denominators are not the same. Okay, so what do we do here? So if this is the case, we don't have the same denominators, we will use the LCD. But I will teach you some useful tips. If you have trinomials as your denominators, what you can do is you will consider the factored form of those trinomials because you might get the same factors and you can take them as 1. Okay, what do I mean by that? Okay, since 2x and 3x minus 6 are the numerators with their different denominators, so what we need to consider is first, we need to get the factored form of this one. So the factored form of x squared plus 4x plus 3 is x and x here. And here, the factors of 3 in which if we add them, the answer is 4, are 3 and positive 1. Because 3 times 1 is 3, 3 plus 1 is 4. Okay, now we have here another set of factors. So the factors of x squared are x. The factors of 6 such that if we add them, the answer is 5. Those are positive 3 and positive 2 because 3 times 2 is 6 and 3 plus 2 is 5. Then you just copy your numerator first, okay? Now, the next thing you should do is observe. As you can see in this set of factors, we have x plus 3 and x plus 3 as identical factors. Now, what you will do is not to cancel, okay? Not to cancel, because cancellation can only be done in the numerator and denominator. So what you will do here is, you will take it as 1, alright? And then copy the remaining factors. So therefore, the LCD of these two trinomials is this one. Okay? Clear about that? Alright. Now, we will divide this one to each of our denominators, and the answer will be multiplied to the numerator. Same as what we did on the previous example. So, we copy first 2x. Okay? Now, if these three factors will be divided by these two factors, so that is x plus 3 and x plus 1, x plus 3 and x plus 1, that will cancel them out, alright, leaving you x plus 2. I will repeat. If you have three factors, these three factors will be divided by these two factors. This will be cancelled, right? Leaving you x plus 2. And that x plus 2 will then be multiplied by your numerator. Okay? So now you have the equivalent fraction for this one. Now you will put the plus sign there. Okay? And now you divide these three factors to these two factors. We have x plus 3 and x plus 2. X plus 3 and x plus 2. Therefore, this will be the one that will be leaving, alright? So that is 3x minus 6, you just copy the numerator, multiplied by your x plus 1. Now, if you want to ask me, Sir Ash, why did you make a parenthesis for your 3x minus 6? That is because if this whole factors, or this whole binomial, will be multiplied to our answer in the denominator, x plus 1, then we will use the FOIL method later because that will be distributed to each other. Okay, so now we have here. Okay, I hope you got that one. Now, what we will do is we will simplify by using the distributive property. So, we have 2x times x, that is 2x squared. 2x times 2, that is positive 4x. Then, we have 3x here. Okay, FOIL method, first and first, 3x squared. Then we have here, 3x times 1, that is 3x. We have here negative 6 times x, that is negative 6x. And we have here, negative 6 times positive 1 is negative 6. Alright. So, we just copy our LCD. And now we will simplify our numerator. We have an x squared here. We also have an x squared there. So, therefore, our final answer is 5x squared. Okay. We have a 4x here. We also have a 3x and a negative 6x here. So, 4 plus 3, that is 7. 7 minus 6, that is positive 1. So, therefore, the answer is positive x because they are a linear term. Then, for our final, we have the constant term, which doesn't have any other terms that is the same as this one. So, we have minus 6 over x plus 3 times x plus 1 times x plus 2. Okay, so that can be your answer. But some students or some other teachers wanted to simplify this one by using the FOIL method. So you can just do so. So what you can do here is you just apply the FOIL method of the first and then you again distribute it to the third factor. Now, how do we do that? Somehow that will be very tedious, but let's consider that one. Okay, so how do we multiply these three factors or these three binomials with each other? Remember that the first two trinomials, if you multiply them, that will be this answer because as you can see, all right, they are just the same. Okay, so this is the result of the first trinomial. Okay, and then you will multiply that to our x plus 2 here. Okay, so how do we multiply this by x plus 2? So as you can see, this is the answer for the first two factors. So that is x squared plus 4x plus 3. You will then multiply it to the other factor that is not the same as the other two. So that is x plus 2. So what you will do here is you just apply the distributive property. So first is you distribute the x squared. Okay, so that will give you x cubed plus 2x squared. Okay, and then you multiply your 4x to be distributed to the Next factor, that is 4x times x, that is 4x squared. 4x times 2, that is 8x. And lastly, we have the third term to be multiplied to the binomial. We have 3 times x, 3x, and 3 times 2, that is 6. Okay, so now what we need to do here is we just combine like terms. So in combining like terms, we have x cubed, 2x squared plus 4x squared, that is 6x squared. And we have 8x plus 3x, we have 11x. And we have plus 6. Okay, so therefore, the simplified form for x plus 3 times x plus 1 times x plus 2 is x cubed plus 6x squared plus 11x plus 6. So you could also write 5x squared plus x minus 6 over this answer. So that is x cubed plus 6x squared plus 11x plus 6. Okay, so these two answers, they are just the same. Okay, so whether your answer is like this or whether your answer is like this, you are still correct. So this example may be very challenging to you, my dear students, but always remember that the general rule is that if you have different denominators, what you will do is you get the LCD. Now, for monomials, you just use the least common multiple and get the highest exponents among the variables. While in such trinomials or binomials, what you can do is you can consider the factors in which the identical factors will be considered as 1. So, for you to master it, you can just rewind these last two examples that we have for you to have a strong foundation about adding rational algebraic expression. And now, this is the time that I will challenge you whether you have understood our topic. And here it is. If you like this video, hit the like button and the subscribe button. That is, if you are committed of learning mathematics the easy way. Thank you.